So good morning. I am Wookie Komosa, and my mentors were Emmy Longnecker and Paul Zyman. Let's go ahead and get started by addressing the elephant in the room. I have been told that I actually wear a lot of the same clothes, and apparently this makes me a cartoon character. So let's go ahead and lean into it. And this is my main character arc here. Thank you, Dana. This is episode 1 of Future Dr. Wookie, some Coke Curl. Okay, so the spectroscopic measurements of chemical composition of organic aerosol particles collected at urban and rural locations, Colorado, or some Pope Curl. Okay. This is chapter 1, the particular matters of particulate matter and why it matters particularly. Okay. So what exactly are we talking about here? We're talking about air quality. This is actually split into 2 different sections here. Okay. We've got PM 2.5 and PM 10. Don't let the name hang you up. This is actually particulate matter, and the number after it is actually the size of the particle in microns. Okay, 1 micron is actually 1/60th of the width of your hair. Okay, we're talking about one of these sides. We're not talking about the other. So what are we not talking about? So we can eliminate that. PM10 is the one we're not talking about. That's actually made in solid state, stuff like wildfires, as well as liquid state, stuff like sea spray. Okay, both of those get filters out by the nose, which is why we're not talking about it. But what does this mean for Californians? It means they have a snotty attitude. Okay. We are talking about PM 2.5, which is made in the air state. Now, we can't actually talk about this without talking about VOCs, okay? Now, I know what you all are thinking. Velociraptors on cellos? No. We're talking about volatile organic compounds, okay? That's carbon-containing compound that has something else attached to it and is prone to reaction, okay? That's an umbrella term, okay? Then we have the biogenic side that actually feeds into that umbrella stuff that's made by animals and plants, as well as the anthropogenic side stuff that's made by humans in industry, as well as combustion. Thank you. Okay, so all of those feed into the VOC umbrella. Best way to think about it, if you can smell it, it's a VOC, all right? Now, yeah, I should move along. Okay, so VOCs are actually react with one or both of the sun and oxidizers to form an absolute car crash of a compound that actually end up with a functional group that we can use to backtrack to the original VOCs, but we'll worry about that later. Those actually end up, when a car crash, you pile up here that don't get filtered out by the nose, they end up deep in the lungs, end up in the bloodstream, and that's what we're talking about. Why? We'll talk about that later. Okay, everybody got that? Any questions? Too bad, we're moving along. Okay, all right. Now, we did actually sample 1 week per site. Okay, there were some logistic hiccups in that. A little bit of Wookiee wisdom in order to sum up that logistics hiccup. Nothing will screw your day up faster than a truck. Nothing. Okay. All right. And we had 3 sites: 1 rural, 1 urban, and 1 suburban. CUMRS, Mountain Research Station, was our rural. CUUMC was actually our suburban, and Ascent Denver, think I-70 and Pecos, was our Denver site. Okay, so 1 week per site, 3 different sites. Okay, now what are the dishes that we held out? Okay, because a lot of atmospheric sampling is just holding out a dish and seeing what lands. Okay, so the 3 dishes that we held out were our high volume sampler, or MCV. This is our time-based sampling. Okay, so at 3 different times a day, we'll be running 3 different filters. Okay, that cuts everything down to the gas phase. Okay, we also had the Moody, which is our size sampling. Okay, that's actually a constant run machine, and it'll split things out as you go down into different particulate sizes. Okay, now we also have our filter sampler. It was the only one that actually used a Teflon, so we actually nicknamed it that. That's also a constant run. And it gives us a general picture. That is our general picture device. We've got our size splitting device in the Moody and our time dependent sample in the high volume. Okay. All right. Now, the extraction process. The time-based samples were so big that we actually had to cut them. Okay. In order to fit them into the flasks. Okay. We put them in solvent in order to get the stuff off of the dish we had earlier. Don't worry, we're going to be referencing that metaphor quite a bit. Okay. All right, so we put the solvent in order to get the stuff off, and then we took the solvent and blew that down in order to concentrate it. Now that's a repetitive cycle process, so we can get enough stuff off of those filters in order to be able to test them, okay? Then we take the stuff that's actually been dried down and we weigh how much masses we got off of it, okay? Then we reconstitute it with a solvent in order to be able to put it on this guy right here and play photonic dodgeball. Now, what does photonic dodgeball mean? It means we're actually measuring absorbance, okay? Measuring absorbance values in relative concentrations. Okay, I know this seems a little bit of a doozy, okay? But we got Denver in black, CU in red, MRS in blue. And these are our general picture samples, okay? What is generally there at those 3 sites, okay? So at the different wavelengths, which you'll see down at the bottom, there are 2 major ones that I want you to look at right now, those 2 right there, okay? And notice how those 2 concentrations between CU and MRS are different, with CU running out on the left and MRS running out on the right. That means we have similar stuff, but the concentration is different, okay? All right, now, moving along, okay? We see, when we're looking at Denver, we see some pretty gnarly spikes, especially when you compare it to the carbon backbone that you see in CU and RMS. I'm so sorry. That is actually what that peak is identified as. It's all of your plastics and that sort of, and hexane and octane and that sort of thing. Anything that has like a carbon backbone to it, okay? Apologize. All right. Okay, so moving along though, we had our general picture. Denver was different. This is actually our time-dependent sample, okay? Morning, evening, and night-based samples, okay? For CU in Denver, okay? Now, if you notice, there are 5 that are generally the same, right? But we have a black sheep in the family, okay? All right, so we know, well, we'll get to that later. There is also the fact that we didn't actually get MRS in on this, okay? We didn't actually have time to extract the samples because I would have had to start the sampling back in the Haitian era, and we just didn't have time for that, okay? All right. Okay, so these are the size separation samples, okay? So as I was talking about before, the Moody, it actually decreases the particle size as you go down, okay? So starting with the big ones up top. Now, we ended up with 3 different classifications of things here, okay? We ended up with the black X's. That was enough to analyze, okay? We got stuff off. We were able to read stuff, okay? All right, the ones in red, not enough came off to analyze. And I'm going to point something out right here that we're going to reference later. These 3 right here, I do have a hypothesis on, okay? Now, if you notice, those guys right there, there wasn't enough coming off to actually analyze. The ones in yellow, though, not enough was on the filter to analyze in the first place, okay? All right, hey, that's enough with the bald jokes, all right? Come on. All right. Okay, so, I swear this guy. All right, so we have the Moody, okay? And if you noticed, on the previous slide, the MRS only had a sample that had enough to collect off of it at the very top. So that's our biggest particulate size, okay? Now that data is actually consistent with what we see in the big picture, okay? Switching over to Denver though, we see the evening-based sampling from our time-dependent and our big picture. Those 2 are actually consistent with one another. They are not consistent with the one sample that we're actually able to pull off with the size-dependent sampling, okay? But that size-dependent sampling is actually consistent with the time-dependent from the morning. So we got something to track down here, don't we? Okay. So from the previous slide, if you, the CU had a bunch of samples that we were actually able to pull off, extract. There's plenty of material on it. All of them are so tightly bundled together, they're almost the same curve, okay? So we're getting, no matter what the particulate size is, we're getting the same stuff off, okay? So with that, the particulate is different. We notice a whole bunch of pollen and salt up at the MRS, which is why we got the stuff in the big size. We had carbon residue, as well as maybe some other stuff along with it. We don't know yet. That was on Denver, and it just kind of stuck on. We had a wide array of particulate sizes throughout the whole thing, though. But the particulate is different, and that's the whole point of this thing. Okay, we proved that it's different. Okay, all right. So future directions. Now, I am curious about whether the mid-range of that red block that I pointed out earlier was actually pollen wing structures that actually impacted at the top of the Moody filter and end up depositing later on, okay? I would like to get that under a microscope, but that's beyond my scope. So, all right. And we also need to do a more complete chemical analysis, okay? Okay, I guess we should actually address why. Why can't I be Sirius? Because Sirius Black is actually played by Gary Oldman, who has an IMDb list a mile long, and is an actor that I can only hope to channel for maybe. Right. Okay. What do you want? Okay. All right. So I guess if we're going to tackle why, do you remember when I was going through all of this earlier, and I said we'll get to that later, the backtracking? Oh, please don't. The why actually kind of plays into that, okay? So as far as this goes, why is kind of a complicated issue. So all right, so in order to have hope, you have to have options, right? That's what this is all about, okay? The way I see it, we've got two options, okay? Either A, we can start buying our air from this guy, okay? Now, I know, I just took you to Mordor, and I'm trying to bring it right back to the Shire here, okay? You gotta come with me, okay? So either we buy our air from this guy, or we tell our congressman to tell the EPA to actually up their regulation again, okay? Now, even though I'm a cartoon character, I think you know which way I'm gonna go on this, okay? All right? Anyway, thank you so much. Y'all have been great. I really appreciate it. Thank you to everyone in the Zyman lab. And a special shout out to Ann. Ann knows everything, as well as the MRS crew. Thank you to all the people that gave us funding in order to be able to do this. It's been awesome. It's been an awesome experience. I do want to have a shout out to the two people in the RECCS program that I just absolutely adore. And just especially to Dana for helping me fix my car. Oh, yeah. So, yeah. Okay. All right. Okay. And thank you to my wife, Maddie, for always being there for me and putting up with me in my absolute ADHD moments. And possibly the hardest slide to make here. All right. I will see you all down the road here. Up next, we have Matt Damon, who's telling us about her.
Couldn't get Matt Damon.
We couldn't get Matt Damon?
Couldn't get Matt Damon.
Okay, all right. I guess up next is Jada Gray.
Oh.
Thank you.
Sorry to break it to you guys. I'm not.